All right. So learning target 14, 15, and 16 are about natural logs, but like the same concepts we did yesterday with 11, 12, and 13. So natural logs are the LN button in your calculator, but all it is a natural log is a log base E. That's all it is. The log base E. So learning target 14, we're just typing things in the calculator. 15, we're just typing things in the calculator, okay? Just like yesterday with the first two. So for learning target 14, if we're evaluating these, if I want to find the natural log of 1 divided by 0.32, I would use the natural log button on the calculator and do 1 divided by 0.32.
Where's the natural log button?
It's right underneath the log button.
Oh, right.
So we have 1.139. Does that make sense to everyone? And yesterday we did anti-logarithms, and that was 10 to some power, because common logs are log base 10. Since natural logs are logs to base E, we use E to some power, all right? So conveniently, again, E to the x power is second natural log button, just like 10 to the x was second log button yesterday. So E to the negative 0.7831. E is a number. This is 0.457. Any questions about learning target 14? On learning target 15, it wants you to convert logs into natural logs, but really all I need you to know is you have 3 equivalent forms of this, okay? So log base 5 of 132, you can just type that into your calculator like we talked about yesterday. Apparently it's math A, log base 5 of 132, and it's 3.03. Or you could use the change of base formula like we did yesterday. So log of 132 divided by the log of 5, which is also 3.03. They're saying to use natural logs, though, so the change of base formula also works for natural logs. So I could also write the natural log of 132 divided by the natural log of 5. Anybody want to guess what that one is? So they're all equivalent. So all of these are equal to each other. Just know that. Okay? Do I need to do the second example?
No.
Okay. That's learning target 15. Questions about that? All right. So 16, we're actually solving equations. Now, if you notice, all of these have an E in them. If your equation has an E in it, then you want to use natural logs to solve it. And I'll explain why in a second. So if we're doing the first equation, we're going to take the natural log of both sides, just like we took the log of both sides yesterday. So I have the natural log of 18. By taking the natural log, I can move the 3x to the front, and I have the natural log of E. Remember, the natural log is just log base E. So the natural log of E is the same thing as log base E of E. So if I'm looking at this part, log base E of E equals x. If I rewrite that, e to the x equals e, so x equals 1. So the natural log of e is just 1. It's like I'm doing 3x times 1. All right, that's why I'd say to use natural logs. Because you have an e in the problem, use natural logs. Most of the time, you're going to be able to use something where it multiplies out by 1. Okay? With that being said, I have natural log of 18 equals 3x then, because 3x times 1 is just 3x. Does that make sense to everyone?
Yeah.
So then how do I solve this equation?
About 3.
Perfect. So the natural log of 18 divided by 3 is 0.963. Questions about the first example? I can rewrite it. Thousandth or hundredth is fine. All right, on the second example, please try to solve the equations as much as you can before you take the natural logs of both sides. So for example, in the second one, we have 10 equals 5 times e to the 5k power. Divide that by 5 first. Then take the natural log of both sides. Again, natural log of e is just 1. So have the natural log of 2 equals 5k. It's just like the last one. So 0.139. Questions about those two? Then I want you to do the other two on your own. Even though they're inequalities, you solve them the same way. The other two on your own, and we will look at the answers together in a second.
But what about the iron or the LN?
For L and E, it's just 1.
That's good. That's right.
Yes, it is. If you type it into your calculator, Cyrus, you're going to get 1 anyway. So if you forget, just type in L and E. The E button is under the pi button somewhere. Okay, so you don't have to memorize it. I mean, you can type it in. But yeah, you guys are doing the other two. I bet you can.
So L and T is always 1.
Yeah, the natural log of E is always 1.
So just it.
All right, here are the two answers. Can you be done for a second? Thanks. All right, here are the two answers. So make sure you have the right answers.
Hold on. So you divide by 25.
Yes.
And then yeah.
What's the natural log? Both sides.
So you just get X.
Because x times the natural log of E is x times 1, so it's just x.
4. And then you get X.
You just type it in, yeah.
48. Yeah. You just multiply by LN. Start off that way.
Yeah, that gets your variables out of the exponent.
Alright, so the 12 minutes.
1 second.
Plus 1. That means
Times 1. Plus 4.
times add the T.
Yeah, there's a t as the variable, sorry. Okay, so on the homework for Learning Target 16, if there's not an e in the question, you don't have to use natural logs. What does the directions say? But like the first one says 6 to the x power equals 72. Well, there's not an e in that question. So you can just use logs, or you can use natural logs. It doesn't matter, right? If there is an e in the question, you definitely want to use natural logs because this whole natural log of e situation works out in your favor. There is one on the homework that if you need help with, I can help you or you can look at my notes. But 42, you're going to have to use some log properties, okay?